This week's AI shift is not bigger models, it's agents that can actually stay on task. Across web, software, and robotics, the strongest systems are moving from one-shot action to closed-loop control. They read guides, plan, monitor, recover, and even rewrite their own procedures when they fail. That matters because reliability, not raw intelligence, is what turns demos into products. Keep watching, because the real story is how tools, online training, and orchestration are becoming the difference between an agent that acts and one that finishes. Let's explore the first paper. MMG2 skill can agents distill in the wild guides into self-evolving skills. This paper introduces MMG2, Skill Bench, the first benchmark for guide-to-skill learning from in-the-wild multimodal web guides, spanning 130 success-inferable tasks across GUI control with OS World, open-ended Minecraft gameplay with MineStudio, OpenHA, and strategic card play with RL Card. It also proposes MMG2 skill, a closed-loop framework that converts HTML plus image tutorials into editable skill. MD procedures conditions a fixed VLM agent on those skills during execution and revises them from trajectory-level root cause analysis without using benchmark scores. Across 6 VLM backbones, including Claude, Opus 4, 6, GPT 5, 5, Claude, Sonnet 4, 6, Kimi, K 2, 6, Gemini 3, 1, Pro, Preview, and Quindrai, Zex, Plus. The method improves every model domain cell over vanilla agents, with macro average gains of plus 12.8 to plus 25.3 percentage points, and a largest single cell gain of plus 33.33 on game. The Bayesian shows that raw guide prompting can be flat or harmful, while structured skill extraction and trajectory-driven revision are both necessary, especially in game and strategy where revision contributes over 90% of the total gain. For deployment, analyzer-based early stopping is calibrated on success-inferable tasks and saves 25.44% to 52.92% of attempts, while avoiding late-stage regressions that make full-run performance worse than early stop on game and strategy. Let's explore the second paper, OpenWebRL Demystifying Online Multi-Turn Reinforcement Learning for Visual Web Agents. OpenWebRL from UIUC and Microsoft reframes visual web agent training as end-to-end online multi-turn reinforcement learning on live websites rather than imitation from large static trajectory corpora. The framework combines a fault-tolerant browser stack, a 1.3 tool action interface, multimodal context management that can retain only the current screenshot, and trajectory-level judging with MMGRPO. Using Qwen 3 VL 4B thinking, the authors warm start from just 0, 4K curated trajectories, then train on 2K OpenWebRL tasks. The resulting OpenWebRL 4B reaches 74.1% on Web Voyager, 67% on Online Mind 2 Web, and 64% on DeepShop, for a 68.4% average and a new open source state-of-the-art. The paper shows that supervised worm starting matters, but online RL is the main gain source. 4B performance rises from 39.3% at the base model to 52% after SFT and 68.4% after MMGRPO. It also distills an 8B judge from 12.5K labeled rollouts, matching GPT-4.1 level training quality, while avoiding about $545.5 in judge API cost per experiment, and reports that the distilled judge, 8B, reaches 89.8% accuracy and 92.1% F1 on held-out trajectory evaluation. Let's explore the third paper, Volo, a physical orchestrator for open vocabulary long horizon manipulation. Volo, a physical orchestrator for open vocabulary long horizon manipulation, from NVIDIA and the University of Michigan, reframes robot control as physical orchestration. Instead of treating a vision language action model as a fixed executor, VoloAgent uses a VLM to plan, monitor, interrupt, and recover by steering a VLA, WAM, perception models, and grasp, place primitives as callable tools in one closed loop. To benchmark this setting, the paper introduces RoboVolo, a high-fidelity benchmark built on RoboLab and NVIDIA Isaac Lab with 4 suites, 15 task categories, and 126 tasks spanning common sense, memory, complex references, and world knowledge. On RoboVolo, the full system reaches 41.8% overall success, versus 12.57% for a pure VLA, 17.76% for a no VLA toolchain, and 34.97% for a VLA-only ablation, with the largest gains coming from monitoring and recovery rather than open-loop action. The paper validates the design on a real Franca FR 3-cell. Full Volo agent achieves 42.9% success on 14 real tasks, compared with 14.3% for Pi 0.5. Failure analysis shows that completion monitor errors dominate across frontier VLMs, while the orchestrator's recovery loop substantially improves resilience, raising recovery from 13% to 54% on episodes that do fail. The strongest practical takeaway is that long horizon manipulation improves when the robot can switch between learned policies and perception-grounded primitives mid-execution rather than committing to a single monolithic action model. That's a wrap on today's AI paper highlights. Thanks for watching.